All right, Mr. I'm right here for chapter 9. Going to do 9.1 today, which is the Pythagorean Theorem. This is going to be a good chapter of triangle work for us. It'll definitely be a little bit longer, and calculators are vital. A good scientific calculator we are going to need in order to do this. So, starting things off, how do I use the Pythagorean Theorem and its converse? The Pythagorean Theorem states for any right triangle, so it has to be a right triangle first off. So we have to have a right angle. It says the square of the length of the hypotenuse. Now keep in mind the hypotenuse is the longest side, so C is the hypotenuse, is equal to the sum of the squares of the lengths of the legs. So we have a leg and a leg. The two legs make the right angle. The hypotenuse is across from the right angle. Then the equation is C squared equals A squared plus B squared, oftentimes referred to A squared plus B squared equals C squared. I like putting that C first sometimes just so I practice identifying which piece the hypotenuse is. That's the important one. The hypotenuse has to be by itself. The legs can be in either order for A and B, and they get added together. So some common Pythagorean triples. Pythagorean triple is some whole numbers who would form a right triangle. And a common one's 3, 4, and 5. The hypotenuse would be 5 units. The two legs are 3 and 4. That's the one I remember the most. We also have a 5, 12, 13, 8, 15, 17, 7, 24, 25. And we could get to these Pythagorean triples by multiplying these by any factor. So I could multiply these by 2 and I could have a right triangle with sides 6, 8, and 10. Or I could multiply it by 3 and get 9, 12, and 15. Multiply it by 4, etc. Okay? So our first example says, find the value of x and then tell whether the side lengths form a Pythagorean triple. So for us to find x, a couple key things here. First, I want to identify which piece the hypotenuse is. So the hypotenuse is across from the right angle. So that is my hypotenuse. That'll be C. The two legs can be either 1A and B. I'm just going here. And when I set up the equation, we'd have x squared equals 5 squared plus 12 squared. Now for me to solve. 5 squared is 25 plus 12 squared is 144 equals x squared. And 25 plus 144 is 169. And then I need to take the square root of both sides. Now technically I'd have both the positive and the negative for the Pythagorean theorem. I really only need the positive because I'm never going to have a negative length. So x is equal to the square root of 169, and in this case I get a whole number that is 13. So the side lengths are 5, 12, 13. Yes, indeed, that is a Pythagorean triple. Pretty much if we get 3 whole numbers, it's a Pythagorean triple. Okay, so we wrote down that yes, it was a Pythagorean triple. All right, on to the next page. Find the value of x, then tell whether the side lengths form a Pythagorean triple. So, let's see. Again, identify C first. Across from the right angle, there's my hypotenuse, so that's C. I'll let this be A and B. So, when I set it up, C squared is 14 squared equals 7 squared plus x squared. Now when I solve this one, 14 squared gets us 196. Equals 49 plus x squared. I have to subtract the 49. I get 147. And now if I try and take the square root of 147, I'm going to get a decimal. Okay? I can't do it. So I need to simplify the radical. And for me to simplify the radical, I look for the perfect square factor that goes into 147. And that is 49 times 3. Now when I keep those perfect squares, keep in mind we're talking about the numbers 4, 9, 16, 25, 36, 49, 64, 81, 100. We're looking for those factors that go in. And the one that does is 49. It's 49 times 3. So I can rewrite this when I take the square root. So after I take the square root, 49 times 3 is 147. So x is equal to, I'm going to switch this over and put x here. Square root of 49 times square root of 3. Square root of 49 is 7, so x is equal to 7 times the square root of 3. And if you were to get a decimal approximation, that is right at about 12.12. Make sure you read the instructions on what you are supposed to round to. I rounded to the 100th. It might say to round to the 10th. Or it might say to leave it in exact form. Okay? On to our next example here. We have the skyscrapers of a building being shown. And we're supposed to find the length of each support beam. So, support beam goes from here to here. That is my distance x. So, on this one, I'm going to round it because it said to approximate it. So, x is my across from the right angle. There's my c. So, x squared equals, looks like each one of these lengths is 23.26 plus 47.57 squared. So, I'm going to have to use a calculator for this. And I can type this whole thing into my calculator. And when I do that, I'm just going to use the squared button. So 23.26 squared, enter, plus 47.57 squared, enter. And I got 2,803. Now for me to take the square root of that, I need to press the second button and get the square root to pop up. And then I can press second answer down at the very bottom here. I have an answer button, ANS. That puts whatever was here into the square root, which is a lot easier than me typing it in. And I get 52.95. So x squared was equal to 2803.93. Then we take the square root of both sides. And x is approximately, hence the squiggly equal sign, 52.95. And that's in meters. So you're going to need a calculator to do some of these calculations. All right. Go ahead and hit pause and try the next two on your own. All right. Hopefully you had some success. Labeling it out. Here is my C, A, B. X squared equals 6 squared plus 4 squared. X squared equals. So here we got a 36 plus 16. 36 plus 16 is 52. So x squared equals 52. Take the square root of both sides, and we should simplify the square root of 52. And is there a perfect square factor that goes in 52? The one that I can come up with is 4. So x is equal to the square root of 4 times the square root of 13. 4 times 13 is 52. And we get x to equal 2 times the square root of 13. And that's approximately 7.21. And there's our two solutions. So make sure you read the directions to see if you need a decimal or an exact answer. And this is not a Pythagorean triple. All right, next example. Across from the right angle is 5, C, A, B. This is that 5, 3, 4. This should end up being a Pythagorean triple. All right, we'll do a double check though. 5 squared equals x squared plus 3 squared. Make sure C goes by itself. 25 equals x squared plus 9. And then we get 16 to equal x squared. Take the square root. And x is equal to 4. So yes, that was a whole number. So it is a Pythagorean triple. All right, on to our next question here. It says an anemometer is a device that is used to measure wind speed. The anemometer shown is attached to the top of a pole. Support wires are attached to the 5-foot pole to the pole 5 feet above the ground. Each support wire is 6 feet long. How far from the base of the pole is the wire attached to the ground? So I have a 6. My distance from here to here is 5. I need to find D. So here's my C, my A, and my B. So 6 squared is equal to 5 squared plus D squared. And then we'll solve. 36 equals 25 plus D squared. 36 minus 25 is 11. Got to take the square root of 11. And 11 has no perfect square factors, so it's equal to square root of 11. And as a decimal, using my calculator, it's about 3.3. and that's in feet. We found our two solutions. All right. Trying to decide if I want to make a second video to make this into 2 parts, and I believe I am going to make a second video. So that's it for today. Have a good one.